all the previous parts always started like you already had the schema, somebody coded for you, you had the backend server that provides you the data, and we were working with Relay. So I want to talk a little bit about how to design schema, because sometimes you can be in this position to define the schema. And basically, we are currently working on a schema design for search. So this is something that's really happening because we have a chance to do the schema right based on the front-end needs, and guys working on Umbrella, which is our backend for search, will implement it according to this proposal. So the relay on a search can be a real thing. So as I already said, the schema is gonna be designed based on front-end's needs. And this is like one of the biggest patterns when you design the schema. Try to match what the front end needs. Ignore how is it stored in the database, because like it can be many storages, but focus on what shape of data and what kind of queries and entities does the front end need. Build the schema for this, because you will create those components, those fragments. Everything should be focused on the front end needs, and let the backend guys or whoever is managing the GraphQL backend figure out where to get the data, because otherwise you will do a lot of hacky things on the front end and you will have to get those data anyway. So if you build a schema based on the front end needs, you save a lot of trouble for the front end guys, and because of that the front end can iterate quickly, do all the UX things that the UX designers came up with. So that's also the approach we are trying to achieve with this schema design. So this is big picture. This tool is called GraphQL Voyager, and we use it just to visualize the schema. And right now the schema has only one query, which is called search itineraries. Itineraries is like itinerary is all everything that the search can provide. We have a glossary built in Kiwi. So another point is try to have the naming matched or written somewhere. So we have the schema, we have the glossary. We define the itinerary is anything that describes how to travel from point A through many other points to point Z, for example. So we have called the query search itineraries, and the result of the search itinerary query is union type. So that's something Martin already touched. So the happy part is the itinerary connection, where the connection is what the relay describes. And also we give opportunity to have some HTTP errors or some application errors, because that's probably something we want to show to the user. For example, when the backend went bananas, so you want to show some banner. When there is some application error, for example, misused dates, like the departure is after arrival or before arrival, and it was validated on a backend, you want to provide the error back. The standard common mistake is front-end developers try to use the errors field from the GraphQL response, but as Martin already said, this should be used only for system errors, and Relay quite smartly stripped this field in a query renderer. So you have to do hacky things, how to get the errors into some state if you want to show it. So another important approach is, if you want to have some errors being part of UI, make them part of the schema, because once it's part of the schema, you don't need to do any hacky things. Relay just gives you the opportunity to have some component that with fragments can get those data the clean way, and you can show the error or whatever is useful to the user the proper way. So the search itineraries query provides the union. So the happy part is itinerary connection. So we have the edges and page info. You already know why. And what we are returning here is the node, which is the itinerary. And itinerary for us is interface, another important thing in GraphQL schema design, which gives you opportunity, as interfaces in object-oriented programming do. So the common properties are defined in the schema, in the interface, and what's special for the implementation is kept in the implementation of the interface. So here you can see that the implementation of the interface is used in itinerary Oneway, itinerary return, itinerary multicity, and itinerary nomad, which tightly matches the need of our front end, where you can search these four examples. Is it visible? Yeah, hopefully. So we designed also these entities as the possible results, which looks like this. So the itinerary defines, of course, the ID, the price, the provider, and if there is some checkbacks needed. If there is possible to have a checkback, sorry, as a boolean, and everything else is depends on the implementation. So one-way itinerary has only one sector, where sector is like description of the connection, how the flights or buses are really going. But for example, the return itinerary has outbound and inbound sector because it's a two-way. You go there and you go back. For multicity, you have array of sectors, and for nomad, which is hopefully you know what's the feature, you also have just array of sectors. So from this point, the itinerary nomad and itinerary multicity is the same, but on the front end there are slightly different UI. So we rather defined also the schema according to this, because maybe in future there will be even more differences, and the schema is ready for that. One common question about this design was, what if we just give like this shape, don't do any interfaces, and a one-way itinerary would be sectors with the array of one item. The return itinerary would be array of two sectors, and everything else is multicity or nomad, maybe based on some text field like type. You could something like itinerary type, where would be just enum of these four types. So the reason why to not do this is again the strong typed which is given to your front end, because then when you are fetching the data and you receive the data, you are doing something like switch, where you picked what kind of itinerary component you want to render. And if you would have this like hidden logic that it's depend on the amount of sectors in this array, you have to explain this logic to any user who's going to implement this. So you would have to write some more documentation. That means it's not that obvious. For example, guys on a mobile would like to implement this and use this GraphQL. You would have to explain them how does it work. And also, if you do the switch with Flow and the Relay compiler, you can do the switch based on the type name. Yeah, so you have __ type name in the response, and the Flow and the Relay compiler can help you with the values, because it has limited set of these values. So it's more convenient to use on the front end these interface implementations than just have the hidden logic in some fields. Of course, it would work, but the benefits are like you could do some mistakes. There are no static analysis tools that would help you with such errors. So that's why we decide to use these interfaces and their implementations. because obviously there can be much more differences over the time. So this schema is ready for that. Once the product will come with the fifth type of itinerary, we don't have to think how to hack it into the just two generic type, and we can just define another type and start happily using without influencing what was already implemented on all the clients, all of the front ends. So this is an important pattern why to have itineraries and the implementations based again on the front end needs. We have also like now if we look how does the UI on the front end work. So this, I don't know if I can select it somehow. Oh, you can see it. So this is like the itinerary. So it's a return itinerary. It has two, well, it has outbound and inbound sector. And now we have the segments. Segments. And so this is the sector, and this particular flight is called segment. So all the probes that are visible on the front end should be available as the probes in the GraphQL entities. So we need the date, we need duration, we need the carrier info. So if we go forward to these data, for example, price, of course, and so here is the sector, and again you can see there is a carrier info, which is another object, and the duration as the number of minutes, and some info about the stopover, which is visible here. So you get the data, how long does the stopover takes, and if there is a kiwi.com guarantee, or is it guaranteed by the carrier. All these things, and you can hopefully easily start transforming these components to fragment components, where you just define like this segment would be a fragment on segment entity demanding just the fields that are shown here, and these components would be composed together to provide all this rich component in the search page results. Some more, the info is written here. We have the documentation, so we tried to make it. Now, how do I increase the font? So some written rules. As I already said, make it really compliant. That's very important. Try to prefer connections, for example, over the lists, because then you can easily use those first, last, and any pagination. Also, the relay updates, I think, work better with connections, because with arrays you have to do all the manual work. Union types instead of merging responsibilities, as I already mentioned. And also, don't try to overuse non-null fields on response fields. Of course, for input fields, input types, it's very smart to define non-null, because then the relay and GraphQL server gives you immediate feedback when you didn't provide something that's necessary. But on the standard fields, whenever you think that some field will always be there, and you just, as a, let's say, premature optimization, define it as a non-null, whenever there is some error, the field and all the siblings around are not provided, because the whole entity gets null because there was some error. Like the response was defined that the field, the value will be provided, something happened and it's not, and the whole let's say entity is not provided at all, which probably gives not that great experience to the user, as if you don't just provide one field. I hope that's clear. Also, it gives you a hard time with BC breaks in the schema. Once you define something non-null and you later realize it can be null, turning it and like allowing the nullability there is a BC break, which is something you don't want to provide in the schema. So we also defined some naming conventions, like types in a Pascal case and fields in a Camel case. Also, prefix the Boolean fields with is, has, and this. And also, what does it mean to be relay compliant is something you already know, and you now also know why is that important. So having the cursors, having the global IDs, and define the mutation as input objects, which is also very handy. Guys in Artsy wrote a really nice article about how they define schema. So we are basically following their recommendations. I highly recommend to read that. And they are, by the way, providing a lot of good stuff into Relay. So that's basically it about the schema design. Take your time if you want to see what's happening with the. I can make it a little bit less. I will share the channel where this project is being managed, so you can follow if you are interested in this topic. And basically that's it for the schema design. Any questions I can answer? Looks like no. Perfect.
There's a question.
Oh yes, sorry.
Is it possible to add a field different airport to a segment?
To the segment, add what?
A field which should be named different airport. When you have like different airports between two segments.
Oh yeah. Well, if that again, you should ask yourself: is there any front-end need for that?
I suppose so. We have like highlighting for different airports.
Yeah, but I think we covered that with the layover.
I think like in the app there is a some kind of alert if you are leaving from a different airport than you're arriving. I guess that's what you're thinking about.
Oh yeah, it's here in the layover. There is just a boolean is station change, so you can display the warning. So again, it would be probably this is called layover, this part, and if the airports wouldn't be London Stansted but I don't know, London Heathrow, there should be written please take care of changing the airports. So it's part of the layover component. It's in layover's entity in the schema, so it can be easily fetched in the fragment. Yes. Yeah, the question was if you don't know all the data requirements, how to start working. Well, then try to get as much data as you can, really like work in cooperation with UX designers and product owners. Try not to overcomplicate things, not overthinking. Maybe start small, because with GraphQL you can easily add more. And if you just match the domain with like good entities like layover, carrier, based on the glossary, probably the UX designers will not come with anything brand new and crazy. They will also have to be aligned with what's available. So then probably you can easily add and don't break anything. Also, like important thing about naming. If you, for example, have something like you somewhere need to show, let's say, in a station, where station can be airport or a railway station, you probably want to show the name of the city. It would be like tempting just to put a city as a string and display it. But for that, I suggest name it city name. So you leave the city free for the real entity once you need more, which we already did, and we call it location area, because then you probably need also some ID and code. But don't like use these generic names when it's just primitive type like int and string, try to always be more descriptive and leave the generic name for something richer. That way you are still like open for changes where something is being added, and you don't need to do any renaming and other BC breaks just because in the beginning you were like not thinking about like more consequences.
Maybe other question also about deprecating fields. Like, what's the best approach as well to like do it in stages?
Yeah. The question was how to work with deprecating fields. So GraphQL gives you ability to deprecate some or any field. So that means it's not then like visible in the tools like Voyager or Graphical, but it's still part of the schema. You can get some warnings that like you are using something that was deprecated. Try to find what's the proper way, what you should use. And the strategy about deprecation should be provide the alternative, talk to your users. What we, for example, do, we have monitoring of all the queries that are being used. We monitor how many deprecated fields are being used, or before we deprecate, we can check how often is that field being used, by whom is it being used, talk to them if they are willing to start using something new, and over some time deprecate the field, but you didn't break anything. They can start still using it, and work with the users, which are like front-end developers. So measure, deprecate, and honestly, if you didn't fucked up the naming, you can keep it deprecated until your monitoring tells you that it wasn't requested for 1 year. Then you can remove it easily. But if it's still being used and some team probably has good reason for that, leave it there, and they can use it as long as they want. Probably new use cases, they won't use that because they will be warned through the deprecation field mark.